Welcome back. Today, we are pulling back the curtain on Hyperledger Fabric, one of the biggest names in enterprise blockchain. We're going to deconstruct its pretty unique architecture by following one single transaction on its incredible journey through the network. All right, let's get right into it. So here's the big question Fabric was really built to answer. Just imagine you've got a bunch of different companies, right? And they all want to share one single trusted digital ledger. How in the world do they agree on what gets written down, and in what order, when there's no single boss calling all the shots? Well, that's the puzzle, and Fabric's architecture is its really elegant solution. Okay, to really get how this all works, we first need to meet the key players in the system. You can think of them like specialized roles on a team, where everyone works together to get the job done. So let's get to know the who behind the whole process. First up, we have the ordering node, or you'll just hear it called the orderer. Now, the best way to think about this is as the network's central mailroom. Its one and only job is to get transactions from all over the network, put them into a nice chronological sequence, and then bundle them up into blocks. Now, what's crucial here is that it doesn't open the mail. It doesn't check the contents, it just orders and batches them. This super focused job is actually key to making the whole network fast and efficient. Next, you've got the endorsing peer. And this one, it's kind of like an expert committee. When a new transaction is proposed, it gets sent to these specific peers. Their job is to run a simulation of that transaction, using the business rules, that's the smart contract, and then decide if they should approve or endorse it. They're basically the designated experts, the gatekeepers, whose stamp of approval is absolutely required before a transaction can even be considered for the ledger. And finally, there's the committing peer. This is the official archivist for the entire network. In fact, pretty much every peer is a committing peer. So after the mailroom, the orderer, delivers a fresh batch of endorsed transactions, these peers do one last check. They make sure all the signatures are there, and then and only then do they write that transaction into their copy of the ledger, making it a permanent, trusted part of the official record. All right, so we know the players. Now let's see them in action. We are going to walk through the 7-step journey a transaction takes, from just an idea all the way to a permanent record. This is the how of Hyperledger Fabric. Okay, take a look at this. This diagram, this is our roadmap for the rest of this explainer. I know it might look a little complicated at first glance, but it's really just a sequence of 7 logical steps. We're going to break down every single one, starting with that client application up in the top left. So it all kicks off right here. A client application, using what's called an SDK, creates a transaction proposal. Now, this isn't the final transaction just yet. Think of it more like a formal request. The application sends this proposal directly to the specific endorsing peers whose sign-off is needed for this kind of transaction. And here is where some of Fabric's real magic happens. Each endorsing peer that gets the proposal basically runs it in a sandbox. They execute the smart contract to see what the outcome would be. This spits out something called a read-write set, which is just a fancy term for a receipt. It lists what data the contract read from the ledger and what data it plans to write or change. But, and this is so important, the actual ledger hasn't been touched at all. It's all just a simulation. Okay, so once that simulation is done, each endorsing peer digitally signs that result, that read-write set, and sends it back to the client application. So now the application is basically playing collector, gathering up all these signed approvals. It's just like getting all the necessary signatures on a form before you can finally submit it. And once the application has collected enough of those signed endorsements to meet the rules, it bundles the original proposal and all those signed responses into one final official transaction. It then sends this whole package off to our mailroom, the ordering service. The ordering service, well, it does its one job perfectly. It grabs transactions from this app and every other app on the network, lines them up in a strict chronological order, packs them into a brand new block, and then broadcasts this block out to every single committing peer on the network. Now, this validation step is absolutely critical. When each committing peer gets that new block, it goes through every transaction inside. It checks 2 main things. First, does this transaction have all the right signatures from the right endorsers? And second, has any of the data that was read during that simulation changed between then and now? This is a brilliant check to make sure nobody can pull a fast one and change the facts after you've already agreed to the deal. And at last, the journey is complete. For every transaction that passes the test, the committing peer takes that right set and applies it to its copy of the ledger, officially making the changes.
Any invalid transactions, they get noted down too, for audit purposes, but they don't change a thing. The peer then sends a notification back to the original app, letting it know if its transaction was a success or a failure. So we've seen the who, and we've seen the how. But you might be wondering, what's the point of this whole complicated dance? Why did Fabric's designers choose this execute, order, validate model? Let's get to the so what, because this is how it all comes together to build a better platform. You see, this unique execute, order, validate flow isn't just for show. It unlocks 3 huge advantages that make Fabric ideal for business. First off, it actually mirrors how companies already work. Second, it solves a really tricky technical problem that plagues other systems. And finally, it's just built to scale. First, it maps to the real world. Think about it, right? In a real company, you don't need everyone to approve everything. A big payment might need a signature from the finance department, while a shipment needs a sign-off from logistics. Fabric's endorsement policies let you build that exact same complex logic right onto the blockchain. Second, and this is a big one, it solves a huge problem called non-determinism. Imagine 2 people trying to withdraw the last $100 from an account at the exact same millisecond. In a lot of systems, who gets the money can come down to random network luck. And for businesses that need absolute certainty, that's a nightmare. Fabric avoids this completely because the outcome of the transaction is decided and signed off on by the endorsers before it's even sent to be ordered. The order no longer changes the outcome, and that is a game changer. And finally, it scales. Because only a small group of peers, the endorsers, have to do the really heavy lifting of running the smart contract, the rest of the network can just work in parallel. The ordering and the final validation steps are much simpler, which means you can add more organizations and process way more transactions without grinding the entire system to a halt. So let's bring this all home. This whole design, it's not just a clever bit of engineering for its own sake. It's a foundation that's purpose-built for the messy, complex realities of how businesses actually need to collaborate. This quote really just nails it. This separation of concerns, endorse, then order, then validate, is what gives Fabric its real power. It creates a modular, flexible, high-performance system that can handle the complex demands of things like modern supply chains, financial networks, you name it. So that's the journey. But really, the destination is much bigger than just this technology. This idea of getting agreement from the right people before you make something official, well, that's a powerful model that goes way beyond code. So the question I want to leave you with is this. Now that you see how it works, if you could apply this endorse first model anywhere, what broken, low-trust process out there in the world would you fix first? We'll see you next time.